Hello everyone, today we're going to resolve LeetCode daily problem number 2799. Count complete subarrays in array. So, in this problem we are given an array nums consists of positive integers. So positive integer is something from 1, 2, 3 and continuous. So no 0, no -1, -2. We call a subarray of an array complete if the following condition is satisfied. The number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. This is our complete array. And we need to return the number of complete subarrays. So a subarray is continuous non-empty part of an array. So here we have an example to better understand. We have 1, 3, 1, 2, 2. And output 4, so the complete subarray are the following: 1, 3, 1, 2, 1, 3, 1, 2, 2, 3, 1, 2, and 3, 1, 2, 2. And the same goes for nums 5, 5, 5, 5, where output will be 10. The array contains only of the integer 5, so any subarray is complete. So the number of subarray that we can choose is 10. The idea is here very simple. When they mean any subarray, we have following two conditions. The first condition, that any new array should contain the unique elements. So we already understand that we need to use set because we will work with unique elements. And for example, here we have 3 unique elements, so each array should have 3 these unique elements. Here 1 unique element, so each new array should has 1 element. The second step, how we create subarrays, it can be done very easily by doing it with each index. So for example, if we take nums equal 5, 5, 5, 5. The idea of this is index of 0, 1, 2, and 3. That's why we can combine these 0 indexes to make any combination of arrays. So we can make array 0, we can make array of index 0, 1, and continuous. Then we can start with 1, 2, and continuous. Be precise, it can be any value. Then we can start with array 2, and lastly we will start with array 3, the last index. This value is indexes, so it will be all 5, 5, 5, but it's combination. So we have total 10 combination because we can combine 1 for 3, we can combine 2 if I remember, 2, 2, 3, yes, 2 for this, so we have 3. Then we have combination of 1, it can be 1, it can be 1 and 2, and it can be 1, 2, 3, so we have 6. And then the last combination of 0, it could be 0, 0, 1 and 1, 0, 1, 2, and 0, 1, 2, 3, 4. So 4 combination. And totally of indexes. So generally we get the idea. So we can make this combination in brute force approach. It will be quite simple to do. So we will use nested loops. We will use set for a subarray distinct tracking, so we will know what unique elements. Time complexity would be peak of and square, as we will need to check every possibility. So we will not only check array once, we will also check every distinct. So for example, combination of 0 indexes with first, combination of 0 indexes with 2, and so on, so on. And lastly, base complexity will be big of n, as we only use set to store data. So in worst case scenario, if all elements are unique, as for example, not here, we don't have like array with unique elements, but imagine if we have array, for example, 1, 2, 3, 4, then we will store them inside of our set, and it will be big of n. So let's start with brute force story. So imagine you have a row of colorful beads, one for each number in nums. You want to count every contiguous sequence of beads, subarray, that shows all the color used anywhere on the string. So first, you try the simplest approach. For each starting bead, you set an endpoint bead along, keeping a little box set that collect new colors, and as soon as the box has every color, you know that this subarray and any longer one from the same stars counts as complete. Though straightforward, just 2 loops, it is like checking every possible window one by one, which can take a while if you have 1,000 beads, but very easily to implement. So we will start with count, which will be equal to 0. You will return count. Then we will use n of len of nums, and just shortcut. The next, we will count total distinct with equal len of set of nums, so all unique elements, to be more precise, distinct elements that are present in nums. Then we follow our nested loop, so I in range n. Here we declare current distinct equal set. It will be needed to check the distinct elements in subarrays. Then for j in range of I of n, so we are starting the next loop and loop. Next step will be current distincts add nums j. In this step, we add from subarray. So we check if subarray j, the next subarray after, for example, for 1, if it contains all distinct elements. So we will add them to make sure it contains. And then we make check if length of current distinct equal to total distinct, and if yes, count will be incremented by 1. So very simple, we add each element for specific. So if we start like making with this example, we create an array of 1 from I, and we check this and we know that it's not true because 1 doesn't contain 2 and 3. Then we make array 1, 3, we check it, it doesn't work because still we need more element. We make array 1, 3, 1, it still doesn't work like that. And the next we make array 1, 3, 1, 2. As you know, with set, current set also will skip 1 as it will be duplicate. We will have 1, 3, and we have 2, and it's good. That means we can have an array of that. And the last one, we will take the whole array, and it also will be true because a lot of sets will skip 1 and skip 2. It still will have all unique element that we need. So let's run our nested loop approach, and let's pass a test, and let's look at it efficiently. Pretty good, 16. All right, 16. Let's now move to more better approach. So I commented this, and as you understand, it was simple brute force approach. As often have just understand logic, and we just follow this logic of checking each indexes of element to know exactly if it has all unique or it doesn't has all the element that present in nums. So distinct elements. Another approach will be optimized. We will use sliding window. So imagine that you're that checking each elements each time, so each subarray, it's too much. So we notice a key shortcut. Once your window from left to right contains all colors, any longer window extending right further still has all colors. So instead of counting one by one, you can instantly add the length of array n minus right to the answer, counting every existing in bulk. Then you shrink from the left until you lose a color, and repeat this single pass, expanding and contracting your window, finding every complete subarray in line and counting them. So in sliding window approach, we will add dictionary of frequency to track window frequencies. We also will use set, but the next time city will be lowered to peak of n, because single pass. This time we will pass once, and space complexity still will remain of big of n, as in worst case scenario we will need to add all elements. So here it will be quite the same. We will have count equal to 0. We also return our count. We will have n equal the nums, and we will have total distinct equivalent set of nums. But you will add additional two variables. So we will add frequencies, and we will add left boundary, which will be equal to 0. Now we will start from the right. So for right and value, so we will check also value inside of them in enumerate, so all elements in nums. So now we will use dictionary for key value pairs. If we get value 0 plus 1. Next steps will be while length of frequencies equal total distinct count. This time will be equal to n minus right. So we make the same logic as previously, but we make it simple. Instead of checking one by one, we follow by window. So if frequenums from left minus 1, then if nums left equal 0, and we remove 3 from nums left and left will be incremented by 1. Oh, index. Oh, yes, I hear. Oops, frequencies, yeah, frequency of nums. So minus Alright, let's double check it. Count left equals 0, nonsense. Then set if write in enumerator, frequency will be equal frequency get 0 if lemma oh yes, slightly forget to move it inside. Yeah, and submit. And it's very efficient. Yeah, if we don't forget about Python issue is moving to the each line instead of how it's done in Java, JavaScript and as language, and you don't care about columns. So the idea here will be the same as with the force, but we save this additional check for each subarrays by dragging sliding window. So it's allow us to have clear understanding of if we already find some measurement, we just check all other elements by moving window instead of rechecking it again and again. So thank you for your attention. If you have any questions, feel free to leave them down below. Have a nice day. Bye.